Welcome back to Advent of Code. Oh, I ran out of time having a chat on Discord. Okay, let's. It is time for day 5. So I just want to mention that I did some extra benchmarks, some extra refactoring. I didn't try to get it as fast as possible. Instead, I tried to show some of the differences that were interesting from the original solution. So part 2 being the original solution from day 4's video runs in about 50 milliseconds. Like we've covered before, that's pretty slow for an Advent of Code problem. We did some discussion of Tracey yesterday, and really everything was pointing to the hashing being the issue, right? There wasn't a whole lot going on in this program. Basically, everything was being spent in this loop, more or less. So the only change in part 2 rustc hash is to use rustc hash for fx hash set, which apparently I'm going to have trouble pronouncing today. So instead of using hash set, we use fx hash set, which just replaces the hashing algorithm. That's it. That's the only change in this entire program. And if you take a look at the benchmarks, that's a difference of half. So 50 milliseconds versus 25 milliseconds, just by replacing the hasher. Different projects use different hashers by default. For Advent of Code, people tend to use very insecure, very fast hashing. By default in the Rust project, they choose something that's a little bit more secure, and thus a little bit slower. But maybe a project like Bevy, for example, can provide its own hashing implementations, or rather community vetted hashing implementations that are just not as secure because of the use case. And choosing one of those faster hashing implementations does make your program run faster if you have a lot of hashing going on. Now, the other one I wanted to point out is part 2 convolve, which runs in about 4 milliseconds. This was a first step for me because I wanted to potentially write a compute shader to do day 4's problem. And the first step in going that direction would be, how do you set up the data? How do you access that data? What actually do you do to that data in the compute shader? So in this case, this is ND-array powered. This is a 3x3 matrix of weights for how much each role, whether it exists or not, matters. So basically what we're going to end up doing here is taking a 3x3 grid and iterating over the entire 2-dimensional array. The role in the middle is the one we're going to be operating on. And what this is going to do is basically just count a 1 for every role that exists and add those together and give us back that value. So what that means is, given any particular position, if we look at the input, if given any particular position, well, the selection isn't going to work very well, but the 3x3 chunk that position is at the center of, this one is 1, 2, 3, 4, 5, 6. So this number would be 6. Conv 3x3 is just a function I pulled from the ND-array examples. It's not something that is unique or special to this example. I could probably actually reduce this down to something else, but that wasn't really what I was trying to do. So we get the size of our input. In this case, I assume it's going to be a square and use debug assert to ensure that it actually is a square when we run this. I add 2 to the value because when we do a 3x3 window, we still want to process the role or the position at 0, 0. So to do that with a 3x3 window, we have to expand the grid by 1 in each direction. So we set the length to whatever it is plus 2, and we get 1 extra row on every side. And thus our 3x3 starts at what would be 0, 0. But it's actually now 1, 1. Initialize a new multidimensional array, set any of the values that are rolls of paper to a value of 1, and then we loop. And for every loop, we keep whatever the last output was, and we create a new output. We do this because our break condition is if the last output and the next output are the same, then there's no processing happening and we can break out. So we apply this kernel to this multidimensional array. We modify this other multidimensional array that's filled with zeros at the moment. And then if those values that come in that response are under 5, we set those to 0. We set the last result to the new result, and we loop again. Once we break out of here, this will end up with A having been mutated to include either a 0 or a 1 in a float. Because it's a float, I just chose a middle value, 0.5. If it's under 0.5, we're going to consider that to not have 1 in it. If it's over 0.5, if it's a 1, then we're going to consider that to have a roll in it. We're going to count that up, and we counted the original amount of rolls, subtract the new amount of rolls, and that's our answer. So that runs in about 4 milliseconds. I think it's a good base to potentially build a compute shader off of. We're obviously not going to use NDArray if we do a compute shader. That data will be stored either in a storage buffer or in a texture or something like that. But I thought this was pretty cool, and it's just one step on the way. So that brings us to day 5, which I've now spent 9 minutes talking about. Day 4. So we're a little late, but that's fun. Today is cafeteria. As the forklifts break through the wall. Was there a wall of paper? Is that what we were doing yesterday? The elves are delighted to discover that there was a cafeteria on the other side. So there is a new inventory management system. Huzzah. They can't figure out which ingredients are fresh and which are spoiled. By the way, I guess since I have not mentioned it before, the way that you hear me speaking these problems out loud when I read them is actually how I read them. So the areas that you don't hear me reading out loud are the areas that I just completely skipped. So copy of the database is the puzzle input. Database is ingredient IDs, fresh ingredient ID ranges, a blank line, and all available ingredients. So ranges, and then ingredients. The fresh ID ranges are inclusive, so these are range inclusive. 3, 4, and 5 are all fresh. Ranges are allowed to overlap. An ingredient ID is fresh if it is in any range. Cool. There is an any iterator. The elves are trying to determine which of the available ingredients are fresh. In this example, 1 is spoiled because it doesn't fall into range. 5 is fresh because it falls into a range. 8 is spoiled, and so on and so forth. So in this example, 3 of the available ingredient IDs are fresh. Process the database file. Okay, that seems pretty straightforward. So I think we'll just close out a bunch of these files. And we'll create day 5 here. Our input looks good. Our input looks pretty big. I think we're gonna start with U64s from the looks of this. That looks like potentially a lot of numbers. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 2 billion numbers just in this range, which to me says that we don't want to be iterating over everything. So that's basically right out. We've got 185 of these ranges. If they all had something like 2 billion numbers, that would be quite a lot of numbers. So we want to avoid that. We're going to try to do things like contains in range or something like that. At least then we get like 185 checks for each number. I don't know how many numbers we have here, only 1,000. So that's significantly lower than trying to iterate over all these numbers. Not that I was going to expand the ranges in the first place, but just important to note because some of these inputs here, for example, we could just make this 3, 4, 5, 10, 11, 12, 13, 14, etc., right? And there's only like 20 numbers max in this list. So we could just have the 20 numbers, but in our actual input, that's not going to work. What is the actual 3 of the IDs are fresh? So number of IDs that are fresh. So I'm just going to relax a little bit and enjoy writing a bit of a nom parser, especially when the inputs tend to be multi-stage. So especially when we tend to have multiple segments. Now it is fine to say that you could like split this on double new line or something like that. But I like the way that parser combinators compose, and it allows me to write a separate parser for each section. So I'm pretty happy with that. So we're going to get a list of ranges and then probably a vec of numbers. I'm going to just start right ahead with U64s because those numbers in the other problems seemed pretty big. So big, in fact, that, you know, maybe there's a way to do this that doesn't require parsing the numbers, but I'm not going to go there yet, especially for part 1. So here what I'm going to do is a separated list, but it's probably worth writing each individual parser to start with because they're a little bit easier to think about in that way. I just realized this needs to be a vec up here, or this type isn't going to work out. We need a vec of these and a vec of those. This could also be a struct that we return. The tuple versus a struct is not that big of a deal. They are different data types, so I'm not as concerned about it because you're not going to mess up whether this is a range or just a vec of U64s. This is going to return our vec, but we could actually, instead of that, start lower. Basically, I'm going to write this out, I think, in a way that is like fairly boilerplatey. It doesn't need to be written out like this, but doing something like separated pair, complete, U64. I use tag here all the time, even though I could use car. I think this comes in as a tuple, and we can do a dot dot equals B here. I'll hit save so it starts formatting for me, start importing a couple of these things. Separated list is always separated list 1, so let's just stick a to-do in here for the moment. Stick a to-do in here for the moment. Separated pair, complete is character complete. And we've got tag. I think this is going to be the parser trait. So this is going to be separated list 1, line ending, range, separated list 1, and then ranges. So this can actually probably be a separated pair, right? And we do ranges here. We do line ending, and then we do, I don't know, whatever other parser we're going to have. The other parser is just separated list 1, line ending, complete, U64. Like, it's just a list of numbers. So we'll do it like that. So theoretically, this parser should work. I didn't test any of it. Let's say this is ranges and items, parse input. Input needs to come into scope. And then we have ranges and items, which we can, I guess info is fine. Ranges, items, and then test log tests and cargo tests day 5 part 1. And this looks like an issue with the digits. So this is what I thought it was going to be, which is this line ending. So the way that I know that, first off, is there's 2 line endings here. One to get to the space and one to get to the other thing. And then there is also a new line at the end of this input. And it's trying to parse a digit. So that digit is coming from something somewhere, right? And the place that we're parsing digits is all of these U64s. So it's either a range or it's that separated list of digits. Those are the 2 places that we parse digits. In this case, because there's a new line, I know that it's trying to parse this second. There is more error handling, like we can get richer errors out of NOM. It's just usually not that important for Advent of Code. So I think line ending and then line ending, or is it and? I think it's just and line ending. Did I put that? I put that in the completely wrong place, which is why we got ranges from 3 to 5 and items of 10. Where is this? This goes here. So now we are correctly parsing. We're getting 3 to 5, 10 to 14, 16 to 20, 12 to 18, 1, 5, 8, 11, 17, 32. And if we wanted to be specific about it, we could do all consuming to check to make sure that we're parsing all of the input. Now this might run into the new line, but in this case it doesn't, so we're good. So we have all our ranges, we have all our items, and then I guess for item in items, or rather items.iter.map, maybe filter is the right. So I'm going to iterate here. I'm going to filter. This is going to take an item. It's going to ranges.iter.any range dot contains item. And we're just going to count this, I think. And then this is result.toString to get our return type. And I think that should work. That does look like it works. I had that one situation earlier where I said the tests passed in one video and I didn't actually even run the tests. So now I go up and I make sure that I read the test every time. So we don't really need these range logs anymore. Cool. So we've got our parser. It parses. We've got our items. We filter for the ranges. We check for any. Any is the new thing here. Rus any. Tests if any element of the iterator matches a predicate. So if any range contains it, we stop immediately. That is, it's short circuiting. So anything that returns true, we stop, which is nice because it means we don't have to check the full list of ranges if we find one that is of the appropriate. See, day 5, part 1. And yes, my actual input has that new line at the end. So for me, there's options here, right? I could either make the parser resilient to that new line, or I could not use all consuming. Both are fine. We could do like and opt line ending here. Actually, and doesn't throw that away, does it? So the functions that I've been using here are come from the parser trait. That is the parser trait in NOM. There's a bunch of things here that are interesting, like parse and process and parse complete. And then is particularly interesting because it applies a second parser over the first one that you parse. if you ever need multiple parsers on the same section, which sometimes for Advent of Code we do, and does return the second, and I don't want that, and I know that there's terminated. So now we get 701. This is just checking to like apply one parser and then optionally parse something else and throw it away. And 701, submit. That is the right answer. Perfect. Perfect. So had a little bit of fun today, wrote a couple of parsers. This could get scrunched into a single parser. One of the benefits of writing things in Nom is that you get these separate parsers, which you can test individually if something goes wrong. I don't actually hit many issues because I have been using Nom for quite a long time at this point. But I remember early on, it's especially helpful to split these out into separate functions because the errors become more localized and it's easier to reason about them. So we've got our parser, and then all we do is items iter filter, check if it's in the range, any short circuits if it is, and then we count up the result and ship it. So let's look at part 2. Part 2 is spoiled stuff goes to the trash chute. They would like to know all of the IDs that the fresh ingredient ranges consider to be fresh. An ingredient ID is still considered fresh if it's in any range. Now the second section of the database is irrelevant. Here are the fresh ingredient ID ranges from the above example. They would like to know all of the IDs that the fresh ingredient ID ranges consider to be fresh. So they just want all the ranges. How many are considered to be fresh? Oh, so we just count them? That's the part 2? How many ingredient IDs are considered to be fresh according to the fresh ingredient ranges? I guess we have to merge these is really the thing, right? Because if it's just what we have here, we do have one overlap actually. I thought we didn't have an overlap. 3 to 5, 10 to 14, and 12 to 18. So this would be like 10 to 18, 10 to 20 is really what this range set is. So I guess we can just start with a vec and iterate over it for each of them, and then check to see if the values are lower or included in other ranges. This comes up so often in Advent of Code that there are crates that do this kind of thing. In this case, this stores ranges in a sorted vector, merges overlapping ranges. I wonder if that includes connecting two ranges that already exist with a third. We can look at the source right on docs.rs. So in this case, we have merged range. Insert range is start bound, end bound, self.insert. Insert does a binary search. If there's a match for both of them, then it merges the ranges. If there's a match for the first one, it merges in a different way. If it matches the second one, it merges in a different way. If they both error out, then I think it's new. So, I mean, this seems pretty reasonable in terms of crate dependencies. I have never used it before, so this is something that I've just found, but implementing this doesn't feel exciting to me. So let's give it a whirl. I'm going to use merged range here. There's only one version. I assume this was an Advent of Code project, honestly. There's exactly one release. You know what I did? I made the mistake of putting this into part 1, which is not what I wanted to do. So what's our answer here? I guess we don't need to parse the end anymore, and we need how many ingredient IDs there are. The test results in 14, so we'll put 14 here. We're going to leave the input like this because the input is actually going to be important. This parser is going to change, and it's not going to be all consuming because we're going to get leftover parsing happening here, and we are not going to have items anymore. It's just going to be ranges. So we're going to get rid of some of this extra parsing that's going on, get rid of the line ending and whatnot. This is claiming to be a separated pair, but really at the end of the day, we just want the ranges. So this is actually, you know what? Well, I don't know why I did that. Hang on. Let's back out that change. And then let's just take ranges and put it here. And then we have all of our parsers. I don't destroy any of the code that we wrote because we already have a range parser or ranges parser, right? So now we use merged range. I'm just going to grab this, throw it in here, right? So we have a merged range for range in ranges. We're going to need to insert. Hopefully this works. it would be cool if the application supported just throwing this in, since it is a range. I don't actually know if it does, but it seems like it does, which is cool. So let's info MR here. That's part 1. Let's do part 2. 3 minus 4 overflowed. Does this only work on signed integers? Interesting question. What is our input here? Our input is 3, 4, 5. So really my question here is, if this expects to have negative numbers available, we need at least 15 digits. We can check to make sure that Ni64 matches, which I think we have plenty of space here. So technically speaking, we don't need U64s. So in this entire project, I'm just going to find replace for I64. And I'm actually just going to run this again. This, however, is not part of our application that's panicking. Okay, so let's see. Clippy utilities arithmetic is not what we want. We want, and just to make sure it is the mapped range that's actually panicking here, right? 0. And let's info ranges just to do a sanity check. Weird. Hang on. Rust log info. Okay, there we go. Insert a range that implements range bounds. We'll clone data because it provides a reference. That makes sense. So this takes 2 ranges. These binary search functions are manually implemented. So let me start with a guess here and do cargo test part 2. And let's leave that. You know, it would really help if I actually ran the code with the other code enabled. That would really work. So we've got ranges 3 to 5 and 10 to 20. I'm not entirely sure why we were encountering that 4 issue. Cargo test. I was running the right cargo run bin day 5 part 2. That is a really unfortunate result. Let's do this. Let's do skip input for our tracing. Let's not log the ranges. Let's do info range processing, right? And then we will see at least where this is panicking. And of course this, so let's get the test to run correctly first. Let's do MR. I guess this doesn't expose the data that I actually want, which is interesting. That's what you get for just like choosing a random crate. The internals of this are marked as private, which means I can't access them. Unfortunately, we need this vec, and this doesn't implement like into iter or anything like that. From iterator, partial eq. So yes, it stores them. It does, for the most part, do what we want it to do. I believe, given the opportunity, we have 3 to 5 and 10 to 20. So 3, 4, 5. And 11 is 14. So that is the right number. We just need to iterate over ranges, which is unfortunate. Now, Clippy utilities. That's where our issue is coming from. That seems really strange as a dependency. When was this made? 2023? Use more efficient data structure than a vec. Here's the iter. There's merged range 2. Oh, this is classic open source. This is really funny. So there's merged range 2. People are using this for chunked HTTP audio loading. That's really interesting. Sorry, this is a total detour. It's funny that they say this isn't maintained anymore. I feel like when it comes to open source, especially some of these smaller like utility random crates that people publish, like was it ever really maintained in the first place? Now, we could just implement this ourselves. We could clone the code from the other project and modify it. We could do a whole bunch of things. But I happen to have fun trying different crates out. So while merged range did seem to mostly work for us, there was an actual bug when we went to use it on our actual input. That meant that even if we could get it to work on the test input, even if we did implement that iter, we would still run into the other issue. So here's a different data structure called a range set. New from iter, into iter, filter, Okay. So it filters for range start is less than range end. Perfect. It does a sort by the starts and then the ends. So we can just pass it in. This is basically the code we would have had to write anyway. This does interestingly work on actual ranges, not range inclusives. So we could take that into account here. And instead of using range inclusive, use range. And then this is going to need to be b+1 for that to work. New from iter is private. Okay, cool. New from slice. Okay, new from slice, I guess, is what we're going to use here. That's really funny. So range set I64 is in this case. So iter gives us a value iter. That suspiciously sounds to me like it'll give us everything, but I'm interested, right? Again, one of the things that I find actually quite fun is, yes, so we get iterator over all the values, which means that iter is not what we want. We want, what was it, iter ranges, which should give us each of the ranges, right? 3 to 6 and 10 to 21. And these are regular ranges, so they're not range inclusives. So we can map over this and do a, let's fix our naming here. This is going to be range set. This is going to be iter ranges. This is going to be range end, which I think is a function. No, it's not in this case anyway. Minus range dot start sum. And this is not a loop. This is a result. And this is going to be a sum. So we're going to have a type inference error. Sum is exceedingly generic, and you can add numbers into a type that is not the same as them, right? So in this case, we've changed everything to an I64 right now, right? And we can sum into a whole variety of numbers. In this case, we could sum into a U64, and I think we don't actually need these I64s to be I64s anymore. So I'm actually going to set those to I64s as well. And now our test passes, right? Test process pass. And then we run, and this happens very quickly because we're not actually doing all that much math. And we put this in, and that is our gold star. So I think that my approach here is very much one of discovery, in that I'm interested to see what exists already before I try to implement it from scratch. We tried merged range. Merged range was an open source library that had a fork. We discovered that there was a bug in merged range. Even if we could get access to the underlying ranges, which we totally could have, we could have forked that library and fixed the bug. That was an option. In this case, range set turns out to be, in my opinion, a little bit more comprehensive in terms of what we wanted. It has a couple of versions published. These are all in 2025 as well. So this was published sometime this year and updated multiple times. It's also really interesting that this is one of the utilities for a TLS notary. I don't know what this project is, but having a utility that is used by a semi-serious project, which, to be fair, I don't know anything about this org or the project. Okay, I did click on this link, but it is just a bright white page. So there's no dark mode for us on this page, but this does exist. Unfortunately, the larger project isn't something that I trust very heavily after looking at the pages, but the underlying util seems to do what we needed, at least for Advent of Code. It also feels a little bit weird looking at the downloads here. So this is the one that we just used. This is got, I don't know, 22,000 downloads or something like that. This is a range set that has existed for what feels like approximately the same amount of time. Feels weird that they both showed up this year. You can see that there's a ton of this class of library though, in terms of implementations. There's also this package, which I think I actually want to use instead. So range map seems to have all the documentation. Insert a pair of key range and value into the map. If it overlaps with any existing range in the map, then it will be partially or completely replaced. Cool. And one of the reasons that I think that is turning into a how do you choose open source libraries kind of video, but I think that one of the things that gives me more confidence here is that this has way more downloads. A lot of them came within the last 90 days. So if you just multiply this, then you get, This has been around for downloading for not all that long, maybe. But it's got 300 commits, seems relatively active. There's a bunch of contributors. The README also gives me confidence. They offer certain data structures and explain sort of how to pick those data structures, which for a data structure crate is pretty solid. So this is range map, and if you go to the dependents page, you can see who else is using it. Cosmic Text is using this, which is a pretty relevant project. Samply is using it. F-Frames is using it. F-Frames is like a Remotion, but for Rust. I haven't checked in on that project in a while. I wonder how it's doing. And if we check the dependents on this other crate, it's not used by anybody. So between that and the the homepage that I read earlier, I really want to avoid using it, actually. So let's stick with what we have already. So a minor set of refactoring later, and our tests are passing and we're getting the right result. Now we're using range map range set, which requires us to construct a new one, iterate over those ranges, insert them into that range, and then we can iterate over that and do exactly what we were doing before. So overall, that's pretty good. We could go back now to what we had before, which in this case was, we were using range inclusives, and this was ... equals. So we get to get rid of this little +1 now and actually use the data as we got it. This would need to become a range inclusive set. And then these, I believe, are functions, but you'll see that our ranges no longer include that end value. So in this case, because we have an inclusive range, we need to bump that up one and then do our subtraction. Oh, obviously the subtraction order doesn't matter, but that gives us what I believe is the result. 84863, 84863, that looks right to me. So yeah, a little bit of kind of how to choose a library on crates.io. Pick something that you're comfortable with. A couple of the things that I look at. And while we didn't write the library ourselves, all of the library code is here in open source. So this seems to be a pretty well documented library from a source code perspective, as far as I've seen as well, which is really nice. My impression of the library is that this range map is the root of it. So if we look for insert, then we end up with range start wrapper, which has a little note here that says, hey, go look at this other file if you want to understand what this is doing. And some really nice comments for like, if there are stored ranges, where they will be. So overall, I think that's it for me for today. I think that the library we landed on is a solid library for doing what we're doing. I think that writing it from scratch wasn't feeling particularly interesting to me at the moment. And in production code, I would love to use something that's a little bit more polished than something that I wrote in, half an hour. That's not to say this library would particularly solve all my use cases, but it's already taken into account things like working with and without standard. So overall, I'm happy with this. Hopefully you enjoyed that, and I will see you tomorrow for day 6.